Hello, welcome to my YouTube channel. In this series of my video, I want to talk about the failure in the space industry and the lesson that we can learn from them. In this video, I talk about the failure in a Antares rocket, which was happened in 2014. It was October 2014. A rocket shortly after the liftoff has a problem, and the safety personnel manually exploded the rocket. They did that in order to minimize the damage to the launch pad area. Meanwhile, the team started to collect the debris for future investigation. 3 teams are built up to find where the problem is. One team from Orbital ATK, who was the owner of the Antares, one team from NASA, and one team from International Space Station or ISS, because the cargo was planned to deliver to the ISS. The teams can easily find where the problem initiated. It was from one of the engines of the rocket, and specifically a turbo pump. But why a turbo pump failed was a question among the teams. Let's keep the technical detail for later and look at the problem from the other side. In the 70s and 80s, NASA designed and developed a space shuttle in order to deliver payload to the ISS and also help a commercial company to deliver their cargo to the space. They plan to frequently fly to space with the 5 space shuttles that they have. Unfortunately, a disaster happened in 1986, and the Challenger space shuttle exploded during the liftoff, and 7 crew members were died instantly. NASA decided to reduce the pressure of the frequently fly from the space shuttle and put time on the safety of the space shuttle. So they use other rockets for commercial cargo and only use the space shuttle to deliver payload to the ISS. It works well until 2003, when another disaster happened and Columbia space shuttle exploded during re-entry, and again 7 crew members were died. This time NASA decided to retire the space shuttle by 2011. This make a gap for US government to access to the ISS. They have to make a deal with the Russian and use Soyuz to access to the ISS, which was not pleasant for the United States. So there was a gap in the space industry. On the other hand, Obama also pushed the private sector to be involved in the space industry. So it was a very good time for private sector to design and develop a rocket for US government. So it was a very good time for private sector to design and develop a rocket. In this situation, Orbital ATK come to a space industry with a rocket named Antares. They design and develop an Antares and buy components as many as possible from off the shelf. In this strategy, they could reduce the time and also the money, so it was very affordable for them. They bought an engine from Russia, which was 40 years old, and the engine was produced during the Soviet Union, but it works perfectly during the previous launch and also the test until 2014. Let's go deep into the technical problem. We talk about a turbo pump was failed. In the proportional system, the load from the engine and turbo pump is tolerated by a roller bearing. And in the Antares failure, a roller bearing failed during the launch. But why a roller bearing failed was a question about between NASA and Orbital ATK. Orbital ATK believed that the manufacturing error caused the rocket to fail. They said that they collect the debris and found the roller bearing which has a scratch on that, and it's the Russian company who make this roller bearing. They are responsible for this failure. But NASA believed that even though we can see the scratch on a roller bearing, but it is not 100% sure that it produced during the manufacturing. Maybe it produced during the excessive ground test. They have some reason for this idea. First, they said that 4 months before the flight, there is another failure on the test, and they found the same problem in the roller bearing. So probably during the test, this failure happened. Another reason is that they investigate all the spare parts and also previous engine. They couldn't find any scratch on the roller bearing. Only one of them, which again has an excessive test, has the same problem as the one which is failed. And the third reason is that there is no documentation for this roller bearing because it is 40 years old. So it is difficult to say that the manufacturing error is the responsible for this failure. All in all, they decided to close the investigation with the funding that they have and make recommendation for future launch. So they make the recommendation to replace the engine totally and also make more accurate acceptance test for the engine. And for the management, they also make some recommendation for better communication between two parties and also the documentation, because it was the beginning of the collaboration between NASA and the private sector, and the documentation was not completed. So they found where the gap is and make a better documentation and contract between them. The recommendation works perfectly, and Orbital ATK could launch Antares again after 2 years in 2016, and it was a successful launch. In between, there was another company who played a role in the failure. It was Aerojet Rocketdyne, who helped the Orbital ATK in design the propulsional system. They believed that the foreign debris in the roller bearing could cause a failure, but the Orbital ATK didn't believe so. In order to close the discussion and disagreement, Aerojet Rocketdyne paid $50 million to Orbital ATK. Sometimes you have to push on the limit, even though it is risky, but you learn from that risk, and it is only time and money you spend for that. If the human on board, the story is different. It is not only a failure, it is also a tragedy. But for a situation when there is only a cargo to the space, it makes sense to make a risk and produce the rocket very fast and buy product off the shelf and launch the rocket, even though the chance of the failure. The cost of such a failure is huge. Imagine you will lose a rocket, a cargo, the damage to the launch pad area, the time for investigation. All of these cost a lot of money for a company. But at the end, it is profitable to make such a business with this amount of risk. and the learning from the failure is much faster and more valuable than the normal practicing without making any experiment. I hope you enjoy this episode. I will come back to you with investigation on another failure in a space industry.